So we just have a little bit left of this packet to finish. And then we have the beginning of packet 8 ready for class also, for next week. So we only have basically 2 plus today left. So
the quiz is Tuesday.
And we'll have a quiz on Tuesday over packet 7.
Are we gonna have a quiz on 8 or are we?
What do you guys want to do? I can just make up some questions and say these are good ones to study.
Is packet 7 what we pointed out today?
Packet 8 is what you picked, what you did today. So packet 8 should be the amino acid metabolism stuff. So packet 7 is the end of lipid transport. So the end of today's stuff will be for the quiz. So we already talked about the fact that those LDLs and cholesterol ester circulating can lead to atherosclerotic plaques. And so the biosynthetically derived cholesterol and the dietary intake of cholesterol is going to be the determining factor on whether you have excess cholesterol esters. And so if your body biosynthetically derives a lot of cholesterol, you should counteract it by having a low dietary cholesterol intake. And cholesterol is hidden in a lot of foods, so you do have to be careful about what foods you eat if you're trying to do a low cholesterol diet. And so remember, we can take those bile salts and those steroid hormones and the membranes and use it to reduce the concentration of cholesterol. But in general, if you just don't biosynthetically derive it or you don't eat it, your levels are going to be normal or fine. But the atherosclerotic plaques are going to be a problem. So one of the reasons that you can get heart disease is for a genetic factor. And we're going to talk about all the different types. This is familial hypercholesterolemia. And so we're going to go through each of the different types for it, but this is a pretty common one. And the cholesterol levels are so high that children get atherosclerotic plaques. So you'll diagnose it very, very early because their cholesterol levels are incredibly bad. So ideal LDLs are less than 130, and the units are milligrams per deciliter, and I will double check the unit on the other chart, and HDL of greater than 60. And the chart that has all of the concentrations on it looks like this, and I think I printed this one out for you on the big page. I think I did. Oh, it's on the same page. It's a half-page one. So a lot of times people will use the milligrams per deciliter or the millimoles per deciliter, but milligrams per deciliter is the more common version for that. But of course, you have to be careful to make sure you're comparing apples to apples. So if you have good HDL levels greater than 60, but if you have less than 40, you are going to be targeted to say that your HDL levels are not high enough, that you definitely have a risk of having high cholesterol and having problems associated with high cholesterol. So the total cholesterol values can be over 239 is considered high, and less than 200 is considered ideal. So that's total cholesterol, so that's LDL, HDL, and triglycerides all together. And so if you kind of break those apart, if you have greater than 60 as from your 200, that should leave LDL to be in the 130 range. So you don't want to have your LDLs be really high. Like you don't want it to be a big portion of that 200. So the triglycerides of 150 is a good value for, or less than 150, and these are fasting ones, so that you haven't eaten in 12 hours, so you should not have any circulating triglycerides. So non-HDL cholesterol, and then some people like to do a ratio of your triglycerides to your HDL. And so less than 3, and you are being considered in the optimal range for the triglycerides versus HDL. So that would be ideal. So these patients have LDLs of over 190. So their cholesterol level, their total cholesterol level just with LDL is 190. So even if they have a normal HDL level, that's going to put them at 250. And some patients even have higher than that. And so some of the patients that are not even the type 2A, the cholesterol familial ones, people have cholesterol levels over 400. And it's amazing. Okay. So there are 4 different genetic defects which can lead to those symptoms. And so these are going to be patients that have LDLs that stay circulating. So we talked a little bit already about what potential causes could be from the processing. So like the endogenous pathway. So what did we say some of those potential problems could be?
The receptors are defective with their shapes.
Yeah, exactly. So a lot of this is going to happen in the receptors, and something wrong with the LDL receptor, or something wrong with creating the little endocytosis process, or recycling the receptor. So one of the symptoms, or one of the causes of that high cholesterol, is the defective synthesis in the LDL receptor itself. So something wrong between the translation of the protein and its processing and sending it to the surface of that liver. So transport can also be a problem. So if the protein is synthesized correctly, getting it to the surface of the liver cell can be a problem. And then we talked about binding of the LDL. So if the receptor doesn't recognize that correct ApoB100 protein, you're going to have problems binding the LDL lipoprotein complex to the receptor patch, and you're not going to be able to take it out of circulation, and the LDL will stay in your bloodstream. And then this last one is the one that involves the clathrin proteins. So the clathrin protein is the one that's going to help form those clusters at the bottom of that endocytosis process and create a vesicle out of the LDL and the receptors. So these all can contribute. Patients can have multiple versions of it or a single version, and it's enough to give them that hypercholesterolemia. So when we have hypercholesterolemia, there are 2 different classifications. We call it primary and secondary. So
Is this on the New York? I don't know.
Oh, now you do. I knew I had a big stack up here for a reason.
Oh, that's extra.
So the hyperlipoproteinemia, this is going to be the generic name for any condition that is going to be high HDL, high, well, not HDL, but high LDL, high cholesterol esters, high triglycerols. Those are going to be the condition that's going to cause the problems of atherosclerosis, the fatty liver, all that stuff. And so when you have, there's two different causes for it. Primary, so that's genetic. So it doesn't have anything to do with your diet. You can try to change your diet, and it still results in having hypercholesterolemia. And that's much less under your control. So some people you can try to deal with having the genetic problems, but really, there's really not much you can do about it. You can take medication and try to change your diet and stuff. But the secondary cause is absolutely under your control. So the secondary cause is these diseases existed first, and these diseases caused your hypercholesterol. So these diseases were first, and because of these diseases, you now have that secondary effect of having hypercholesterol. So of course the big one is diabetes. So along with the uncontrolled glucose comes these high levels of cholesterol, and it usually is associated with obesity and a reduced healthy diet, et cetera, et cetera. So they're just as much. You still have to treat them just as much as you would a familial one, but you also have to treat the underlying cause of the high cholesterol. So there are 5 different types, with type 2 kind of a little split type 2. But so there's a total of 6 different versions of hypercholesterolemia broken up into different types, and the classification is called a Frederickson Classification. And so Frederickson is one of the physicians who started looking at characteristics of blood lipid profiles. So once you took the patient's sample, what can you do to try to classify the cause of their high cholesterol and break it down into the type of lipoprotein complex you would see. So depending on what type of lipoprotein complex you're going to see, that will help you determine what type of, you're diagnosed what disease you have and what type of hypercholesterolemia you have. So one of the genetic ones, we did this one. So, so large amounts of LDLs will create high LDLs and atherosclerosis and high cholesterol. And so we know that high amounts of triglycerides, so TGs are triglycerides. Oh, sorry, that one's hyperchylomicronemia. That's what. So chylomicronemia. So that one's going to be high levels of chylomicrons, and that's why we have high levels of triacylglycerols. So excessively high triacylglycerols, remember, that would be part of the exogenous pathway. So high levels of those triacylglycerols that don't allow the chylomicron remnants to happen and the uptake of those chylomicron remnants into the enterocytes. And if you control that, your cholesterol level will stay high, your triacylglycerol specifically level will stay high. So high levels of chylomicrons will be a type 1. So this one would be an exogenous pathway. So when we do the hypercholesterolemia type 2A, the 2A, the 2B still have the LDL issue, but the type 2B has a combination of not only do you have high cholesterol, but you also have high triglycerides. So the type 2 will be just high levels of LDL, but the type 2B will have high LDL and high VLDL. So the type 3 is going to involve IDL. So defective ApoE is going to cause IDL. We should be able to look back at that circulating pathway we did before and see the conversion from IDLs to LDLs. So we can see the problem associated with that. So where does the IDL fall in the pathway? So this one's exogenous, this one's endogenous. What do we say about this one? So the page that that I'm talking about is the one that has the enterocytes on the upper left-hand corner. Yeah, that one. This page. She's gonna laugh. So the next one is called type 4, and it has high triglycerides and high VLDL, but cholesterol and the phospholipids are not. So you don't have this. You don't have high cholesterol like you would with the type 2B. Your cholesterol levels are normal. So that's an unusual situation to have this hypertriglyceridemia. And then the last one's called mixed. So this mixed one, kind of what its name says, it's got high levels of chylomicrons with or without high levels of VLDL. So you've got high total cholesterol and you have high triglycerides. So this one is going to kind of be both pathways. And that one will be endogenous. Okay, cool. So here's the color version, and some of you have the color version of this slide. So these are the 4 types of the Frederickson classification, and these are patients' blood samples. And for the Frederickson test, you let it sit for 24 hours at 4 degrees C. So what I want you guys to do is I want you to look at these and match them up to the characteristics from the previous page. And I want you to come up with lipid classification or components that you can observe as you look through each of these blood samples. And I'm going to turn off the lights because you can see them a little bit better when you look at it in the dark.